second problem, on first look, it kind of resembles a breadth-first search problem. But when you look at the constraints, you will see that okay, you will either run out of memory or you will get time limit exceeded. And so we have to rethink the problem. So like the problem is saying that we've been given 2 points, right? And you can imagine them being in some sort of coordinate system. And so this is our origin 0, 0. And say the starting point is probably here and the ending point is here. And he's saying that can we get to the ending point in the time given us? So there's some time limit that we've been given, and at every step we can make and at every second we can make one step in either this direction, this direction, this direction, this direction, this, that, that, or that, right? And so they're saying that in before this time runs out, can we get to E in time? So like there are 8 possible directions that we can do. And so like on first glance, you would think that okay, if we apply BFS, then we will get like the shortest distance, and then we will check if the shortest distance is smaller or equal to T. If it is, then it is possible. If it is not, then yeah, it is not possible for us to reach there before T. But the problem is that the constraints are very big. The constraints are like a billion. So if you have a billion, then yeah, you are either going to run out of memory because like at every step you must store like the neighbors, and so like there will be a point where like there will be like close to a billion neighbors, and then you are going to run out of memory, or you just run out of time. So that forces us to rethink about the problem again. So it's like looking at the problem carefully, we start to make some observations. It's like these steps, if I take a step up, am I getting closer to my objective or I am moving away? You see that like I am moving away from my objective, right? And so these steps are not useful because these are taking me away from it. The only steps that seems to be bringing me closer to my objective is when I move either in this direction, or in this direction, right? But even the two that we said are even better, you can tell that this one is the most efficient one since it does both of these. And so we can start with this idea that okay, if this if where we are starting from and where we want to go, if they are in different quadrant, right, then we can just keep on doing like this motion, right, until um, until we either lie on top of where we want to go, or we are say like somewhere like here, like on the same like say horizontal as it, or on the same vertical as it, right? Because if we are on the same like there are three possibilities. You see that we keep on moving like this until we lie right on top of it. That is one. We keep on moving like this until we lie on the exact same horizontal as it. That is the um, second option. Or we keep on moving until we lie on the same vertical as it, and that is the third option. So if we lie on the exact same point as this one, then yeah, we are done, right? We will just count like the number of like um, diagonal moves that it took for us to reach here, and we'll just check if it is smaller than this. But if we get to this point, then we are just like going to subtract the difference in the x's, or if we get to this point, we'll just subtract the difference between the y's, right? But even making this observation is not enough. And like let me also put this, like it is not always that we are going to make this downwards move. It could be that our objective was, say, if this was a certain point and our objective was here, then we'll move in this direction. If our starting point was was clear anyway, say if our starting point was here and our objective was here, then we will go in this direction. You see, we'll go in this diagonal, right? And if say if our objective was here, then we will go in this direction, right? But if say our objective was here, well, then we have already met one of the conditions that we said we are supposed to stop, because like they lie on the same vertical. The same thing will happen if our objective was probably here, then we will stop because they lie on the exact same horizontal, right? And so even this observation will not even help us pass the constraint, because remember the constraint is a billion. So even doing these like constant like subtractions is not going to run the code in time, but it will not use like a lot of memory. So let us think about it, right? So even after seeing this one, we are still not in the clear yet. One small observation that we can see is that all these like diagonal movements that we are going to make, whether it is in this direction or in that direction or in that direction or in that direction, it is just doing one thing. It is just subtracting or adding or doing something to these like x and y coordinates that we've been given of our starting point, and like it is doing it until either our starting x and y coordinate is the same as our um, is the same as our objective x and y, or one of their coordinate values become the same, right? So instead of like doing these single subtractions, we can just find, say we have like our starting x and our starting y, and this is our target x and target y, right? If we can find like which one is closest, like between like the start x and start y and the start x and target x and the start y and the target y, if we just know like which one has like the smallest difference between them, absolute difference between them, then we can just like say that okay, if if we make that move, then one of these ones is going to become zero, right? So like if say if this one, if like between the starting x and the target x had the smallest difference, then making that amount of difference, whether it was addition or subtraction, will, like will bring this one to lie on top of that one, and then we will make like the exact same like addition or or subtraction here, and then that will put this one on the exact same like either horizontal or like vertical, right? And so after we've done that changes, then whatever is left is just going to be like the difference between like this and that, after we have subtracted or added d to this one. And this is a solution. And this solution will pass our test cases, because if you look at this one, we are not using any loop. We are just doing simple additions and subtractions, and it is going to take place in constant time using constant space. And so that is the solution to this problem. It is very simple, and this is the code. The code is saying that okay, and yeah, there is this one more thing that I forgot in the question. It is saying that we must make a move. right? So like even if at the beginning we are lying on our objective and the time hits one, we must make a move. So like if we are even on our move, the only way we can count it as true is if we move away and move back. And so that is the first this one. So like I'm saying that even if we start on our objective and the timer is one, then like that means that we cannot reach it, right? Because like we use that 1 second to move away, then we need another 1 second to move back. So like that is this one. And so now that we have sorted that simple like edge case out, we now do what we are talking about. So what this part of the code is saying is that if I like if x and y, so like this code is just like the first condition is just determining how the direction in which we are moving, right? So like this one is determining either if we are going to move in this direction, either we are going to move in that direction, or in this direction, or in that direction. So that is what it's doing. And then after that, remember I said that we'll find like the minimum difference, right? The minimum difference between the start x and the start y. And then after we found it, that will be like our first move. So like after we found that one, we moved it to this one, and then we added or subtracted it from the start x or y, like depending on which like direction we are moving in. And finally, we just did the final move that I said. We just subtracted um, um, the remainder from this one. So like after we have put them on the same like vertical or horizontal, subtracting x or y will just give us 0, and this one will just give us that small value left for us to hit our target. And so like this is just a solution, and this should work, and it works in constant time. So submitted, and then it passed. This is me during the contest. Yeah, I made quite a bit of errors, but it's fine. And so yeah, this is like the perfect solution. You cannot do any better than this. And yeah, I mean in the contest it was 0 seconds, but I guess for some reason